Great. Then we hand it over to you, Jim.
Yep. Okay, great.
All right, streaming should be all going.
All right, excellent. Okay, all right. Maybe one more minute. I've got 13 people on now. Oh, Ken, do we have a link to the presentation, a PDF file or something that we can put in the chat for attendees?
A link to the presentation.
Or you can email me the PDF file and we can get it out that way. But
I do not have one at this point, but I can get you one.
yeah, that's fine. And then I'll just mail it out after the fact.
That would be better.
Yep, that'll be great.
Some people can do 3 things at one time. I'm a single-threaded person.
Well, I do 5 things at one time. None of them ever work and none of them ever get done, but I'm awesome because I do 5 at once. So
I don't do that very well, so I
yeah, I don't do it either well is the problem, but usually I schedule things that way, unfortunately. So, okay. All right, let's see. All right, I'll kick it off. So I want to thank everybody who's online. We'll get started. I want to welcome everybody to the Boston Hyperledger meetup today, and we're going to take a close look at an identity blockchain solution for decentralized digital identities, which, if you're not familiar, is a different way to manage identities. It's a self-sovereign identity model where the user is in control of their identity and their information around it. So I won't go beyond that, but we're lucky to have Indicio.tech today to present what they've done in decentralized identities. So they actually have a solution that Ken will walk through a little bit. It's based on Hyperledger, Indy, and Aries, and uses the Indicio testnet. So with that, if you're familiar with that space, that's great. And if not, please, you'll be able to get more information from Ken. And I will follow up with a PDF file that I will post out on the Hyperledger meetup site once we have the presentation available to us as a PDF. So Ken Ebert is the CTO, Chief Technology Officer at Indicio.tech. And Ken was with the Sovereign Foundation as a software architect and an open standards engineer, providing improved functionality, interoperability, and rich schema support for the Sovereign ecosystem, which, if you're familiar, Sovereign is one of those identity providers using self-sovereign identity, one of the bigger ones that's out there for sure. He's focused on open standards, such as verifiable credentials, DID specifications as well. There's standards organizations around that. And then he's been promoting compliance with standards on self-sovereign identity at Sovereign and other places as well. So he's currently working on verifiable credential standards, which are critical so that you can automate, in a sense, I'll call it digital credentials easily. And he's working on that. So with that, Ken, I'll turn it over to you.
Great, thank you. First of all, I'd like to thank the sponsors of the meetup today for allowing us to get together and have a good chat about decentralized identity. I'm going to give some background information about decentralized identity, a little bit about our company and who we are, and then dig into some of the details of how networks are structured and how, in particular, the Indicio testnet operates so that you can be informed on that. One of the things that I like to do is make changes in the world. And one of the exciting things is to participate in a new technology that's coming out. So Indicio.tech is a professional services firm. We offer advisory services and technical assistance in trying to get companies to adopt verifiable digital credentials and help get rid of the roadblocks that get in people's way and help them get to market. And that's a fun thing to do, to watch companies go from just getting started to a deployed solution. We came from the three founding members of the come from sovereign background, and Heather Dahl is our CEO. I'm the CTO, and Helen Garneau is our marketing director. You might recognize those faces as formerly being with the Sovereign Foundation. As Sovereign switched to an all-volunteer model, many of the people who were at the foundation decided to join forces and work on, instead of Sovereign, to work on coordinating the efforts of other companies and helping assist move that forward. We are very much focused on the open source community. That's important because the efforts that we put into the community are then available for sharing with all the companies who are participating. Using that technology is sometimes challenging. Open source communities don't always coordinate releases well. They don't necessarily have the full documentation or support that you might find in a professional company. So one of our jobs is to help make that open source community effort productive and then useful for other people. We have a very experienced technical staff because most of our staff came from working in the Sovereign ecosystem for many years. And so that's who we are. In the problem of identity, the internet was set up originally without a clear way of identifying the participants. The famous cartoon of on the internet, nobody knows you're a dog, is quite true. My cat frequently participates in my Zoom meetings, and nobody invited the cat to participate, but sometimes he manages to put his face on the video or use the keyboard in inappropriate ways without properly identifying himself. The internet identity systems are familiar to most people. They look like email or username and password kind of thing. They are, there are lots of them around. The systems allow for you to have an interaction with a website or a services provider, but typically the service provider is the one that owns the identity. They control it, and you interact with it. And so the center of the universe in those systems is the centralized identity provider. We have multiple of those types of providers out there. They range in size from the giants of the internet to the teeny tiny websites that you interact with on a daily basis. I think I have about 100 or more different logins to different sites that I have to use a password manager to keep track of. Most of those sites don't interact with each other. They are individual silos of information, and they're not, the interoperability comes at a fairly high price to get them to integrate their data and make it available so you can share any kind of login information or credentials between the different sites. Most of them don't interoperate. That's the exception rather than the rule. When we look at decentralized identity systems, it's a different story. You're probably familiar with decentralized credentials. You most likely have one of those in your wallet or one or more of them. They are physical identity systems where there are issuers of those credentials who give you a card or a driver's license, a passport, medical insurance identity card. Those types of things allow you to have in your possession something that is a transfer of knowledge from the issuer to you, and then you can present that information to businesses to say, yes, I am a trustworthy resident of the state, therefore allow me to purchase this because I'm old enough. I can show you because it's on my driver's license. You trust the driver's license because it mostly is not hackable, or it takes a fair amount of effort to hack my driver's license, and therefore you trust that the information has been reliably delivered. But it's an ad hoc network. It's decentralized because the person holding the the credential is not in a central location. It's in my wallet, not in a central database or anything like that. The information came from the DMV's database, but was transferred to this credential. When you move into the world of digital identities and decentralized identity systems, they work in a manner that's very similar to physical credentials. Instead of having a piece of plastic that's has a logo or something embossed in it to help, or a hologram on it to help add trust to it, they come with cryptography and a digital mechanism for transferring that information securely. One of the neat aspects of it is that the holder of the credential is still the person in charge of taking that data from a trusted issuer, holding it, and then presenting it in some fashion to a business or to someone else who needs to verify that information. The hologram and the plastic with watermarks on it and fun stuff like that gets replaced with cryptography to ensure that the data hasn't been tampered with, either en route or by the holder themselves, so that the data that comes through is trustworthy. And there's an element of trust that is human kinds of trust, where the human business owners trust the humans at the Department of Motor Vehicles to behave in a certain way, and that these identities are not tampered with along the way. That's some of the fun stuff. When you do that, it stands the model for how identities are managed on its head. Instead of all of the identity being owned by and controlled by the businesses or services that I log into, it's now me who controls my identity, and I can have the credentials interoperate because the integration effort is extremely low. Credentials issued to me by eBay or Google can be used with any number of websites to present the data to whom and when I want to present it. That's a cool thing. Another interesting part about decentralized identity is that if you bake it in correctly, privacy by design can help protect the user from their data being sold or misused in a way that they don't want it to. It's based on things like decentralized identifiers, which are unique identifiers. The use of peer DIDs is another concept where a decentralized identifier can be used in a pairwise relationship with another party, and therefore avoid correlation of a single identifier that's universally used somewhere. Done properly, there should be no personally identifiable information on a ledger. This helps with compliance with things like GDPR or the California Protection Act that specifies how personal information be treated. When you introduce medical information into the mix, it becomes even more complicated in complying with HIPAA laws and other things like that. Doing things in a decentralized way takes that information out of a ledger, out of a centralized database, and puts it in the control of the user. Zero knowledge methods are also an interesting aspect of privacy protection. Zero knowledge methods include the ability to only partially reveal, selectively disclose the information in a credential to somebody else. When I present my driver's license, sometimes I might take my driver's license and hold it up with my thumb obscuring my address or phone number or my birth date. I only want to show them my name and that I'm a resident of the state. Zero knowledge methods allow you to do that digitally and securely without having to, maneuver your thumb into the exact right spot to cover something up. In a decentralized method of presenting credentials, the verifiers also aren't interacting directly with the issuers. They interact with a ledger that provides the keys so that the verifiable credentials can be decrypted and then understood without having to go back to the issuer every single time that the data is presented. It allows the control of the interaction to be managed by the person in the middle, instead of having the issuers and verifiers collude and do whatever they want with your data. This brings us to our Indicio testnet. Indicio has set up a system of verifiable credentials based on the Hyperledger Indy code base. Hyperledger Indy is the original source of the model that Sovereign uses. It's the model for a number of other ledgers as well. But that code base has a purpose-built ledger and associated technology stack that goes with it to support these decentralized credentials. Originally, the vision with Indy was to create a single network, one network to rule them all. However, that's less the case now. There are multiple ledgers that are in process, and the Indicio testnet was built to help with testing out interoperability of different Indy networks. That's one of the reasons we put it together. We also wanted a place that was free for developers to go play with the network without having to set one up themselves. Setting up a network involves setting up multiple nodes to put together the support for a blockchain so that consensus can be reached about what should be written to the ledger so that it's immutable and not can't be tampered with. Setting up a network of your own is not an impossible task, but it is more effort than we feel like it should take to get people started in using decentralized identity. So having a test network that's free to use that you can go out and play with helps accelerate adoption of use of the verifiable credentials. We also have customers who want a professionally managed network. The Sovereign network was professionally managed, probably by the same exact people that are now operating the Indicio test network. However, when Sovereign switched to an all-volunteer model, most of the staff, 99% of the staff, is no longer there to provide the support nor the professional monitoring of the network. And so some customers, especially those who are putting business critical efforts out there, want something that has the support behind it. So that's one of the reasons we put the test network together. The second reason for putting it together was to foster interoperability testing. It became apparent that there would be more than one network and that the credentials issued on one network and credentials issued from a second network might be needed to be presented in a composite proof. And if you only have one network to test with, it's really hard to test interoperability of the networks. And so we determined that that would also facilitate and accelerate the adoption of presentations using multiple credential networks as their sources. In implementing a decentralized identity system, it's based on the concept of decentralized identifiers. A decentralized identifier is simply a URL that has some method of putting an identity number or DID. We call them DIDs. They're just a string of characters. So in this example here, you have DID. That tells you what type of thing it is. It's a decentralized identifier. This is the method name. In this case, it's example. In Sovereign's case, it would be Sovereign, and Indicio's, it's Indicio. And then there's the identifier. It also has path, query, and fragment components to it to help further retrieve specific parts of a DID document. A DID subject is the thing that this DID identifies. It can be any type of entity. The most typical use case is a person, and that's why they associate a DID with a person. It can be an organization, such as a business or a government, or it can be a thing like an IoT device or something that has absolutely no, you can assign DIDs to things that don't have electronic capability and manage the DID on behalf of that non-digital asset as well. DID documents contain things like keys and how to send messages to the subject. So DID documents, when you resolve a DID, you get back information that says, here's how you encrypt a message for me, and here's the address that you can send that to me so that my agent will pick it up and I can respond to it. So DIDs are a central piece of the puzzle in implementing a decentralized identity. There's still ongoing work to standardize DIDs and work out the exact syntax of the DID itself, its method, and the path and queries and fragments and what those all mean in a standard way. Most of that work is happening at the W3C and is expected to take another probably 18 months before final standardization happens. Typically, standards are pulled together after some innovation has already occurred and people have got some great ideas, and then I want to consolidate those ideas into a uniform way so that everybody can use them appropriately. So once you know that you need a DID, you need to get one to interoperate with the Indicio test network as well. So we have instructions in a website that allows you to go pick up and register a DID on the test network. Because the Indicio test network is a public permissioned network, you have to have permission to scribble on it. Hopefully you don't scribble too much. That's the early stages while you're figuring things out. But after you got things figured out, you're going to write to the ledger in a coherent manner. And as you write to the test network, the things you need to write are your public DID, things like a schema or a credential definition, some revocation information perhaps. But those are the types of things that get written to the ledger. That enables you to issue and others to verify those issued credentials. So you go with, you create a DID and you register it using the self-serve app so that you can now have write privileges on the network. They're free, they don't cost anything to get them. You do have to commit to not violating the terms of use on the network, such as not writing PII to the network. That's the biggest restriction on the network. And then you, in order to connect your app to any particular network, you need to have its Genesis file. And that there's a link posted that will be in the PDF that's shared at the end of the presentation as well. But pointing at the proper Genesis file, you are able to initiate communication with the network to first read or write particular transactions to the network so that you can establish the identity and the schemas that you'll be using. So the free to use part of it is kind of in a use as you will. There's also an option for paid support to have people walk you through any problems that you might have in using the network. A network is the Indy networks are layered, and so there's different components to the system as a whole that allow you to have the full functionality that you need. At the very bottom, you have the DID registry and schemas and so forth, and that's basically a blockchain of multiple nodes that help synchronize the writes to the ledger and allow you to be assured that nobody has changed who is controlling that particular DID or what the schema was, so that you can't change the schema after you wrote the credential and issued it to somebody, that those things remain unaltered and viable and useful still. And so that's the purpose of the registry or the ledger, is to record those transactions that need to be immutable and saved for verification later. Above that, you have peer-to-peer communications, the agents and the DIDCOM layer. The agents represent, an agent in the financial world represents somebody who's going to act on your behalf. The same thing is true in the digital identity, decentralized identity space. Agents represent an entity, whether that's a business or a person or an IoT device. And they're supposed to act in the best interests of the entity that they represent. So that terminology is chosen for a reason. They establish through key exchange, something like a Diffie-Hellman exchange, a secure connection. And that secure connection has all encrypted communications on it, so that whether the transport is unsecured, like an HTTP connection or a serial wire, those connections are not secure by default. But because all of the data that transports between the agents is encrypted before it's sent and decrypted when it arrives, the transport doesn't need to be secured. You can still send messages over HTTPS, you're just encrypting it twice. That secure connection allows for protocols to be established on top of that secure connection to do the next layer up, layer 3, which is the credential exchange. Credential exchange is the process of issuing a credential. A credential contains some basic information, metadata about who issued it, its timestamp, what their DID is, where the keys can be located on the ledger to properly authenticate that the credential indeed was signed by its issuer and that it hasn't been tampered with. Then it contains attributes about the subject. The subject's usually a person, but it could be a business or anything else, but you're going to make some statement about them. In a driver's license, the attributes might be my first names, my last name, my date of birth, my driver's license number, any restrictions. I have to have glasses in order to drive safely. Those types of things are contained in the credential. The holder receives that credential and then is able to present it in a secure way to any verifier. The intended use of my driver's license originally was so that I could present that to a safety officer who's verifying that I have the right to drive and that I'm complying with the restrictions on my license. I'm not allowed to drive semi-trucks, and I have to wear glasses. And if I'm showing that credential to the safety officer, then I can prove that I have the right to do that. In a digital credential or a physical credential, the DMV doesn't control who I present it to. I can present it to a store to say I'm over 18 and I'm allowed to buy this type of product, or I can show it to the airline to show that I am eligible to fly on a domestic flight. They didn't intend that as the original purpose. An ad hoc relationship can be established where trust in that credential is useful to other people than the intended use in the original issuance. At the very top, there's a governance framework. Governance frameworks determine who are trusted issuers, what types of schemas should be used, what are acceptable presentations to ask for. If you're trying to verify somebody's age, you probably don't need to know their eye color. And so governance authorities can issue kind of the rules of the game for well-behaved players to use, and that helps establish further trust in the system. If they say, these are the trusted issuers, if you want to get a college degree showing up as a credential, you probably shouldn't trust Ken's online college degrees for free issuer, because I'm not part of the governance framework. This allows for the verifiers to have greater trust and assurance that the data that they're receiving is from legitimate sources and that has not been fraudulently put together to help fool people. It's more trustworthy than that. As we look at how that interaction occurs, in order to have that data be verifiable, behind the scenes, some blue stuff here has to happen. The issuer has to write their DID, which identifies them to the ledger. They put their schema, credential definition, revocation registry here on the ledger. Then they sign and issue a credential with the data on it. When the holder presents that data to a business, the business can read from the ledger without having to contact the issuer directly the DID, schema, credential definition, and revocation information. And then they can verify that the presentation indeed contain a statement signed by the issuer. This allows them to have greater trust in the data. And the trust is implied here. They don't have to actually contact the issuer directly. They can have a high level of trust that the data hasn't been tampered with because the cryptography helps assure that. That allows for, even if the issuer goes away, if they go out of business, the data that they wrote here is still valid and still can be verified at some later date. So that educational institutions that have gone bankrupt and disappeared, their diplomas can still be verified online and still be useful to the holder. Networks need node operators in order to make them be independent. If you have a private network, you can operate the nodes all yourself. That's great, but that's kind of a counterproductive in terms of decentralizing things. Typically on an Indy network, there are multiple node operators, each independent, and they're usually distributed geographically and politically to ensure that there's no disruption of the service due to a natural catastrophe or some kind of political event like a war or a change in regime where they shut down all the node operators in that country. This allows for the network to have more resiliency to any types of faults, whether it's a hardware fault, a natural disaster, or a political event. We are looking for additional node operators to expand our network to have it be more resilient. We offer technical training and assistance in helping those node operators come up to speed, and then the professional monitoring and management of the network. And there's links here where you can find out more about that if you're interested to become a node operator. In the governance framework, that establishes the rules of the game, like I said. Who are the trusted issuers, schemas, best practices, how do they do revocations, things like that. They publish rules to their community members or publicly to let people know how to interoperate with that network. However, you don't really know for sure how issued credentials will be used. They can be used outside the governance framework, and the user determines that, and the verifier determines that, not the issuers. And so that's an important part to keep in mind, even if there is a governance framework. Ad hoc usage is the usage of those credentials in a manner that was unanticipated by the governance framework. If you don't have a governance framework, it's completely ad hoc. At Indicio, we've tried to build on what was there in the community, in the Sovereign Foundation and the Trust over IP foundations, to take the things learned there and to simplify as much as we can our governance to make it easier to use, easier for the lawyers to understand, so that they'll actually give you a green light for your project. And we recognize also that the governance is something that is not a static thing. It's something that changes over time. New things come up. When the GDPR came out, it had an impact on how identity systems could be operated safely and in compliance with the law. And it put some additional constraints on the system. And so you need to recognize that your governance isn't a once and done thing. It's a set something up and then review periodically to adjust for changes in the environment or the legal or regulatory frameworks. And in operation, the validator nodes run and are managed by the node operators. Each node operates its own server and has the software installed on it. This is the Indy node code and the Indy plenum code. So Indy originally contained all of the software that you would see on this diagram, but as it grew and additional community members became involved, the node code and plenum code were separated out from the agent code. There's a second library that's used in the node and agent code, and that's the URSA library. That's a cryptography library. It's now, I think, targeted to be shared among at least 8 different projects. And I think that 3 of them are on board now, and that number is growing. Cryptography is something you don't want to roll your own. You want to have the benefit of broad community analysis of cryptography. And so the URSA project was spun out of Indy in order to provide an independent cryptographic library that had broad community review and support for the cryptographic primitives. Above that, you have the agents. I divide them up into 3 types of categories. You have mobile agents, which typically operate on mobile devices. They don't have fixed endpoints, so that they need to supply a fixed endpoint for people to talk to them. A mediator agent is involved. A mediator agent is a simple agent that does things like store and forward messages, and that's about all it does. There's not a lot of complexity in the mediator agent. It does have to know how to decrypt messages sent directly to it and re-encrypt or forward an encrypted message onto its eventual target mobile agent. The other side of this are the enterprise agents, and they operate in 2 different modes, either as a built-in, where the agent is rolled into the enterprise application directly, or there's a cloud agent with some type of a web UI to talk to the cloud agent to represent a larger organization. Most people don't need one of those, an enterprise agent or a web UI. They prefer to carry their identity information around with them on their mobile phone that they take everywhere anyway. There's nothing that prevents a human from having a cloud agent and a web UI to manage it. It's just less convenient. These enterprise agents have the different protocols implemented that they support. It's discoverable. So you can say, do you support the basic message protocol? Do you support issuance protocol? Do you support verification? And any of the other protocols that are embodied in an agent. The basic things that you need to do are connect, message, and issue or verify a credential. Those are the 4 most rudimentary ones. In terms of the code architecture, the Indy Hyperledger Indy plugins exist with Indy Node and Plenum performing the basic backbone work of the ledger, the cryptography library supporting all of the components that need cryptography and other projects that support it. On the agent side of the stack, you have an Indy resolver that knows how to talk to the ledger. You have the SDK that allows for higher level functions to be built, such as building a credential. You have the different agent, the Hyperledger Aries agents, and then there's apps that are built on top of those agents, both enterprise and mobile apps. Examples of these are the Aries Cloud Agent Python that lives up here. It doesn't have a particular UI built on top of it. It doesn't have an enterprise UI on it. It just has the agent, and you can use RESTful calls to control and manipulate the agent to have it perform its tasks. Mobile apps typically have the agent built into the mobile app, and there are examples of both proprietary and open source mobile apps. When a network is operating, it's important to be able to monitor the network and correct problems before they become big problems. Ledgers are set up with redundant nodes so that they can tolerate failures. In the Indy system, the default configuration is to tolerate a single node failure in a 4-node system and remain in consensus. If you get 7 nodes, you can tolerate 2 of those nodes being down, and so forth. So it's 3, for every 3 nodes that you add, you get another layer of redundancy and ability to handle another fault before the network goes out of consensus. The monitoring tools, we've just contributed some monitoring tools back to the Indy community to help with real-time monitoring of the nodes and the network. It's important to have that for the staff to be able to quickly identify nodes that may be in trouble. They have a memory problem or a hardware failure, get them resolved and back online before the network experiences any outages. Monitoring tools are great. If you don't have any staff to monitor the monitoring tools, then you're still in the same position of being at risk of having network failures occur. Examples of what the monitoring tools look like. It's monitoring the nodes in the Indicio test network, taking a look at their uptime. Some of them have been up longer than others. So you can see that that nodes have been gone in and out of uptime without the network having ever gone down. Right now, all of the nodes in this particular snapshot were in consensus, and they were within 1 second of having synchronized time. So this gives the ability for the staff who is monitoring the thing to be able to keep up with what's going on. Private networks, sometimes there are legal restrictions on a government, for instance, not being allowed to run on a public network. They need to have their own private one. Or they may have an instance where the data isn't intended to be generally publicly shared, and they want to have their own private network for some reason. We also offer services to help people spin up those types of networks. They can use them for testing out something in private. They can be used for a solution that is targeted for eventual deployment in a private way that doesn't allow for public rights to the network, or it may have different governance rules that prohibit it from operating on a public network. So having available the ability to spin up your own decentralized network is important. Right now, there are, in addition to the Indicio network, there's the sovereign network. They operate 3 networks actually, a main net, a staging net, and a builder net. Their builder net is for testing out new releases. Staging is for pre-production environments. It can be reset. And the main net is for production environment. Kiva operates a ledger. They're not super chatty about it, but they operate a ledger for their own personal solutions, and they have their own governance rules. Their Bedrock has announced a ledger that they're trying to spin up. It's a consortium, I think, of 9 different companies right now that they're trying to get going. It's not live yet. The Indy ledger has been up since April of 2019. That's a Finland specific ledger put in place by, organized by support with the government in order to provide within Finland the ability for new companies to adopt decentralized identity and to test out their solutions. But it's a geographically limited one. Not on this list because it just appeared about 2 weeks ago, is the ID Union network. It's again geographically limited to companies within the borders of Germany. So those are some other ledgers that exist today. I know of at least 2 others that have publicly announced that they will be operating ledgers soon and are in the process of getting those done. And 3 other networks that are not announced yet, but that are headed towards launch in the near-term future within the next 4 to 6 months. So the trend toward additional networks is growing, and nothing prevents other ledgers from being put together for specific purposes as well. When you look at where the standards efforts are in decentralized identity and what's happening there, the most active community and the most successful community is built around Hyperledger. It has the largest number of contributors. I think we're in the 250 range of number of contributors on the Aries, Ursa, and Indy projects. These are all related and help put together the functionality that you need to have a full stack of interoperable agents and be able to issue hold and verify credentials in a very secure way. The Aries and Ursa solution support zero knowledge methods, including selective disclosure, predicate proofs. Predicate proofs are where you say, show that my age is greater than 21. I don't have to reveal my age, but I can use a predicate style, a comparison, to show that either a number is greater than another number or within a certain range. There's also standardization work going on at the DIF. This DIDCOM work, the communications protocol work, was spun out of the Aries group. The reason it was put into the DIF was to get a broader audience for interoperability and to include other parties that were not participating in the Aries discussions. The W3C also sponsored the original verifiable credentials data model specification work that has been turned into a recommendation of W3C. So many companies are trying to adopt that. It doesn't talk about implementations, it talks about data models. And so there are a number of implementations, and there are at least 3 different signature styles that were recommended in the data model, and others are allowed. So I would expect to see additional signature styles such as linked data signatures and the JWT signatures, ZKP signatures that were in the data model to be expanded to include others going forward. The DID specification work is also going on at W3C, and it's about 9 months into the process, getting close to a year, and it will probably go on for at least another year. Newly formed is the Trust Over IP Foundation. It's been in existence for about 3 months and is making progress on governance, but it's still fairly early in that life cycle of specifications happening there. I put a ... down here because new organizations are becoming involved as the work expands, and I expect to see additional standards bodies become involved as time goes forward. If you think what markets might be benefiting from this, I put in a list of 4 of them that I think are heavily impacted, but every single market that has some type of identity in it, every website will probably be affected. So if you think, I wonder if my vertical will be affected, the answer is yes. It's kind of like when you go to the fish store and you say, is my Molly fish pregnant? The answer is, how do I determine that? The answer is, they don't give you a method, they just say yes. And so the same thing will happen with these vertical markets, that all of them will be affected. There will be some that will be affected earlier than others, but every market is likely to be impacted. The benefits are the user control of identity, that strong verification of it, and the cryptography that's involved with it. It cuts down on the fraud, and in the financial markets alone, this is sufficient to warrant the deployment of these decentralized identities, to cut down on the massive expenses that are put toward avoiding fraud and remediating fraud once it's occurred. It also gets rid of some of the targets for large-scale hacks and breaches of data, because the data is distributed. There's a number of benefits that are obvious and some that are less obvious, but it's a system where the new laws and regulatory environment towards protecting users' privacy and ensuring that they control their data will ensure, I think, that progress will be made on decentralized identity. I think that Indicio is in a great position to help and assist either through the use of the test network that we have in place, or the consulting services that we offer to help people adopt and move forward in decentralized identity. That brings us to the last slide. Are there questions?
Yeah, Ken, this is Jim. I have way too many questions, so you'll have to stay here till tomorrow to answer them all. But before I ask all of my questions, I'd like to turn it over to the audience. So you've been listening. This is actually an excellent presentation, not just on decentralized identity, and I'll call it the infrastructure that goes with it, but also what Indicio is doing. So I'll just open it up to the audience. Unmute yourself if you have a specific question that you'd like to ask Ken.
Yes, I wanted to ask a question.
Yep, go ahead.
Hi, Ken. Hi, thank you for your presentation. I just wanted to know if biometrics are considered verifiable credentials.
Biometrics are apply to verifiable credentials in many ways. Some people are using biometrics to access the wallets that contain all the keys and so forth. Biometrics are also considered data that can be embedded in a verifiable credential. So I could issue a credential about you that says your fingerprint contains these biometric markers, or your face recognition parameters are in this verifiable credential. They can also be considered PII and should be treated as such. Biometrics play both a role of protecting the data and become the data themselves. And so verifiable credentials are very flexible in what they can put in them. So the attributes can be tailored to incorporate biometrics as well.
Oh, okay, thank you.
Anybody else have specific questions that you would like to ask Ken? Just please unmute yourself and ask Ken. All right, with that, yes, Damon or anybody else?
Oh, sorry, yeah. Hi, Ken, thanks for the presentation. I was just wondering what Jacques was just saying about the biometrics, and if they are both data and personally identifiable, PII basically, how difficult is that to secure it and actually keep it together? How difficult is that to make sure that you don't lose that PII?
The PII is always, in all the verifiable credentials, the holder is the one storing that data. The issuer can keep it around too, and so can the verifier after it's been presented, but they accrue additional risk as they do so. Keeping the data secure is part of the cryptography. The cryptography ensures that only the holder can present the data in a verifiable way. The data is stored in encrypted wallets, so the storage of the data is protected at both the sending and receiving and verifying side. The wallets are all encrypted. The communications channels are encrypted. I think that's the strong point of the system. The weak point of the system is, what do you do with the data, such as biometrics, after you exchange it and pass it around a little bit? If you're having the users send biometric data to verifiers willy-nilly, then you're unnecessarily exposing them to risk. But the process of transmitting it is secure. The process of storing it is secure. That's not the typical issue. If you're using biometrics as the sole identifier of a particular person, then that's also risky, because now you can pass that biometric data around and as though you're that user. Typically, the DIDs are used to identify somebody. The biometric data might be a layer of confirmation.
Yeah.
And that's a more secure model. Peer DIDs ensure that DIDs are not reused for connections, so that as an individual, I might have a DID for every person I connect with, and my wallet manages all that for me. I don't have to figure out that I have 36 DIDs, each unique to the connection that I'm talking to. And so systems that rely solely on the biometric data for identification purposes are, in my view, flawed, because they expose the end user to both correlation and to abuse of their biometric data.
So Ken, following up on that, one of the issues and one of the benefits, I think, of this approach with Indy Aries is that you can have, you can reduce what I call data correlation by third parties.
Yes.
So because you're getting, I'll call it, these unique DIDs generated all the time. So it's, in a sense, unlike Facebook, if I'm going out to the same site using an SSI identity and credential, in a sense, somebody else who can see what's happening on their site won't be able to know that it's, in a sense, correlated back to Jim Mason directly, or a single user, if you will, uniquely, which is nice. So
Yeah.
that really helps with the new privacy laws and regulations like GDPR and so on that require that
Mhm.
data protection, if you will.
Does indeed. And some of the centralized systems that say let you can use your, for instance, your Google login to go to 26 other sites. You're using a single identifier, and those sites all know it's the same you that is talking to them. And anybody who's listening in on the wire who can hack through that stuff and can see that your behavior is correlated quite strongly across all sites that use the same identifiers, whether they're a Google login or any other single unique identifier. You can abuse verifiable credentials the same way and DIDs the same way. If I use the same DID for every single interaction that I do, I've created a single unique identifier for me, and I've allowed other people to correlate the use of that identifier to track my actions. And the use of peer DIDs and being able to spin those up as kind of disposable DIDs for peer relationships allows you to basically rotate your identifier on every single different connection you have, so that there is no correlation risk.
Yep. Oh, yeah, and on the point on biometrics itself, one of the things you could do is, instead of sharing the biometric data for verification, is just, in a sense, create, I'll call it, custom hashes of the biometric data that would be verifiable that way without actually sharing the data.
Yep, you can do that. You can say, did you use your local authenticator to verify your biometric data that it's really you? And
Right.
proof of that as well. So you're not actually sharing the biometrics, but you're sharing a result.
Yeah, proof of that, which is really what we
Cryptographically
which
proves
you
that
guys want.
you. Yeah, there's a lot of ways to incorporate biometric data. Some are stronger than others, and some are riskier than others.
Sure. Let me ask you, because going through this is obviously very different, what I call IAM, identity access management process, than what the rest of the world uses today, for sure. It's better from a legal perspective, it's better from a controls perspective, and all those other points. The one thing that's interesting, beyond just the networks, I'm actually in the middle of trying to build what I call a valid business case for this, right? So wanting to cheat, I'm asking, do you know of anybody else who's already got what I call a well-defined business case that they have identified? So you were talking about some of the benefits on your benefits slide. If you think about that slide, I think the bottom one says reduces cost for identity management. What I'm really looking for is to find somebody who has that well-defined proven business case, not what I intend to do, but more, here's the results we found kind of a thing.
The number of cases that are deployed in the wild is still fairly small, but growing rapidly.
Yeah.
I think that I've seen a couple of really interesting cases in where the use of it is obscured. They're not touting it as decentralized identity. They're calling it passwordless login. They're calling it secure access control and other things like that. And that's in the access control side of things. Other people are using it in a way that's more transparent, but not fully decentralized. The government of British Columbia's system for businesses are taking public data, creating verifiable credentials that are stored in a public registry. It's not really conforming to the model fully. Although they have, I think, 2 other use cases that are in progress right now that are fully using the decentralized identity model, and with holders holding their own credentials. I don't know if they're touting them from the rooftops yet, but I know that work is going on there. There's other banking applications where they're using it to more securely ensure that their mobile banking applications are talking to the right person and not being man in the middle, or having somebody with a simple username password that can be easily, if discovered, used to establish take over the identity of somebody and do banking transactions on their behalf.
Yeah, I did notice there's a comment in chat from Will Prasher, who has been working, I guess, at the National Health Service in the UK, and has deployed an SSI solution live at that point. So So Will, do you want to open up the mic a little bit and tell us your experience?
Yeah, sure. So part of the NHS strategic direction was keeping doctors and nurses in NHS and not moving out of it. And so they were doing staff passporting, as they called it, as a program of work anyway. As a response to COVID-19, you needed to move doctors and nurses around different hospital sites much more swiftly. And so NHSX, so the NHS innovation arm in England, said, okay, let's accelerate this. Let's do staff passporting. Let's do it with SSI. And we got that live in 16 weeks. Built that with our partners, evidence, so we got those guys. I don't want to bog up this presentation now, but I have to pick up afterwards.
So yeah, Will, your connection was breaking up there a little bit, but basically you're saying it was staff passporting during COVID to try to track where staff were, I guess, where they were moving to when they arrived, that kind of thing.
Yes. On the basis that it's quite expensive and time consuming to onboard new medical staff to new sites.
Great. And yeah, thanks for posting the article as well into chat. So there's a link out there if anybody's interested. I am for sure on following up on that as well. But yeah, as you said, Ken, I think it's a big deal trying to get real world production use cases and saying, you know, here's what we expected, here's what we actually found. And there's both positives and negatives to that. But in a sense, building that is going to be building that repository of, I'll call it existing business cases is really, really important, I think, and then sharing it out there with everybody.
Yeah, I think that you're seeing a large number of use cases that are in the, that have passed the proof of concept stage. They're going into pilot, and then you'll see them roll into production. But I think it's the bigger the company, the slower they move. There's some smaller companies that are going a little bit faster. But if I watch the traffic on, for instance, Sovereign's mainnet, it's way lower than the Sovereign staging net. The Sovereign staging net has a fair amount of traffic growth, and I'm seeing that that accelerating. Our network is seeing growth. The number of companies participating in the ID Union solution and they're spinning up real solutions on access control. You're seeing real life deployments start to occur in an accelerating pace. I don't have time to watch all of the news feeds all the time, but the number of cases that I see going public are with their solutions is growing at an exponential rate.
Yep. Yeah, that's very interesting. One other challenge, I think, and I'm looking at a government rollout, much like British Columbia, the advantage on the organization side is that generally, while organizations do have private data that doesn't get shared, you know, who are the stockholders, what's the capitalization, that kind of thing, that's all private data. The reality is, I can't think of an organization that doesn't want to have a public interface of some type. So the concept of doing what they did with the org book and saying, let's publish, you know, make publicly available at least the identity of these organizations makes sense, and is not a challenging thought in a way to do. So they actually automated and just generated digital IDs after they had their system up and running for all of the organizations they had registered from the existing databases. The individual side of it's more complex. So it's kind of like if, in my case, with the state government, if you were to get a driver's license here and we have, I'll call it the DMV set up for digital identities in a sense, you now get a wallet and you get your ID. And we have your information stored in, I'll call it a state credentials registry. And at that point, you know, maybe you can apply to get a license as an architect or something in our state. But every other application you want to use in our state is not running on digital IDs. They're running on the old, you know, password login kind of thing with single sign-on and so on. So the whole rest of the enterprise isn't tied into that. So for you to use the wallet effectively, one of the things we have to do as a challenge on us, to, I guess, to make the thing useful is say, well, if you're going to go to the trouble of having this thing in your wallet and it only works on 10% of the apps, we have to start looking at something like OpenID Connect. You know, trying to use that as a possible bridge. Has anybody done that in production yet?
Yes, there are people who are doing that in production. There are a number of, so if you look at where the innovation is happening, it's happening in Europe first, and US is second, and Asia, Latin America, Africa are all lagging.
Mhm.
The innovation, if you want to look at where the most innovation is occurring, you would look to Europe and look at the solutions that they're deploying there. They're always, some people think about this as a paradigm shift where you leap from the old way of doing things in a centralized way into suddenly all of the business processes are converted to a decentralized mechanism. That's not reality. Reality is that there are lots of systems out there that are deployed using old style credentials, using old style methods for authorization or for data sharing. And the truth is that an evolutionary path that offers stepwise conversion is going to be far more successful than supposing that an entire leap will occur for an organization overnight. I'm seeing that integration efforts after you finish the pilot type stage, then the integration effort with legacy systems, where it's partially new decentralized identity and partially old style systems is a big deal, and a lot of effort goes into ensuring a smooth transition for the users of those systems. And that's where the greatest success is seen, where you provide a transition path.
Yeah, and our challenge, and maybe most governments are going to approach it like this, we're considering, if you will, saying, okay, if you're coming into our state and you want a driver's license, this is where you click and go apply like you normally do. We'll issue a normal license, but if you check this box, we're going to also issue, I'll call it a digital identity. And if you've elected that option, at that point, you're going to wind up with, in effect, the ability to get an email that links to a website where on your phone, you can automatically download the agent, if you will, and get your wallet and your digital credentials. But then once you have that, as you said, to make it useful, it's not going to help you if I have 50 agencies in the state and only one of them is digital. So that's where that bridge becomes critical for us to get over the hump and say, no, it actually would have value because we're going to find a way to bridge you into the existing identity systems for sure. So that's a big deal.
That is a big deal. And that's where I see the biggest successes happening, where people take into account the transition path and how to ease the pain and reduce cost and risk for businesses or governments to adopt and issue the new style credentials. Where you can show a clear benefit, you can usually persuade people to move. If you are making it more painful for them or awkward, then you're going to lose. So taking into consideration the business's needs and their costs and risks will help ensure a more successful deployment.
Yeah, great. All right. Since I've been hogging the line, I want to ask anybody else on the, at this point, want to ask any more questions before I give Ken back the rest of his day? So if you don't speak up, I'll just assume there's no more questions to come. So I did mention before, we're going to wind up with a PDF version of this presentation tomorrow. I'm going to post it up on the Boston Hyperledger meetup site for everybody to download, make it easy there. And certainly want to thank Ken for everything, not just the presentation, but the great work you're doing as well. That's been tremendous. So I think it's nice to hear from somebody who's much farther down the road on self-sovereign identity, I'll call it infrastructure and support than the rest of us are. So a lot of us are trying to run in that direction, but we don't have, in a sense, the experience that your team does. So it's nice. I think it's worth taking a look at Indicio to see what their testnet is. As you said, Ken, it's free. I can go out there and enroll, in a sense, get an identity and just test it out. And speaking from experience, it is, as Ken said earlier, infinitely simpler to call it join their testnet and get an identity and start experimenting than it is to start, with, I'll call it your next Ubuntu instance, in the cloud somewhere and deploy it all yourself. That's probably months of time, not hours of time or days, but more like months of productivity there. So if you want to understand self-sovereign identity, having the ability to have a playground where you can go out there and actually experiment with the concepts productively fairly quickly is a huge win. So I want to thank you for that. So
we're glad to be participating in this community. We're grateful for the opportunity to come talk with you guys today and give you kind of an update on what's happening with our network and the other networks that are springing up. I think it's an exciting time in decentralized identity, and I'm looking forward to seeing some of your success stories posted as you go live with your production systems.
Great. Well, thank you again, Ken. I really appreciate it. And thank you for Indicio for putting all the work that you guys have been into what you've been building. So we all not only appreciate it, but want to, in a sense, learn from it and borrow from your experience as well. So thank you.
Thank you.
Anybody else have anything else before I end the meeting today? Okay.
Yes, actually, I'm Maya from Indicio. If anybody wants to chat with us, my email is maya@indicio.tech. And thank you so much, everyone, for coming.
Yeah, in fact, actually, I'll change the meetup invite to, if you want, Maya, I'll put your email out there as well. And I already have the, the company website and so on, but we can add your email as well along with the presentation.
Great. Thank you so much. I appreciate it. Okay.
All right. Well, thank you again, everybody. I appreciate it. And this has been very productive. Again, thanks, Ken. And have a good day, everyone. Bye.
Thank you. Bye-bye.